morning. Thanks for the introduction. When Milan asked me a couple of months ago by now whether I would like to present here today, I immediately said yes, and then realized that it would be really hard to fit it into my schedule, so I'll only be here for 30 hours or so, which is really sad because I haven't been to Serbia before, haven't been to Belgrade before, and I would love to explore the city a bit. So maybe next year then, hopefully. I'm amazed to see so many people show up for a conference just about testing. I remember the first time I spoke at a conference about testing, about PHP units, some 14 years ago, and 2 people showed up. One of which came to me after the talk and said, well, this was the only talk in German in this time slot, and I didn't want to go to the other ones, so that's the only reason why I was here. So I only had one. So times have changed. So when Milan asked me, I thought about what would I talk about today. So I thought about testing, moving fast, and okay. So there's this one company that says we move fast and break things, and I thought maybe like a variation of that subject, moving fast without deploying broken things. And that's how I got here. So hi, my name is Sebastian. Been doing things with PHP and to PHP for about 16 years now, which is a really, really long time. I'm driven by a passion to help PHP developers build better software. That's why I started to build tools such as PHP Unit 14 years ago. You may call me a pain-driven developer because I was feeling the pain of not having these tools. I waited a bit, nobody else wrote these tools. So to make the pain go away, I started working on these tools. So that's what I do. I like to share my experience at events like this one, which is why I try really, really hard to make it work. And well, so I was thinking about like a couple of weeks sitting at my desk, what am I going to talk about today? And that's, by the way, my desk at home, which I rarely use because I'm seldom at home. And I was thinking about, what am I going to talk about today? And then the internet sent this video my way. This is from a keynote at a conference on agile software development last week. And if you find the time after this presentation, take an hour that it takes to watch this video. It's really funny. And what's funny about this well, this is Eric Meyer, in case you don't know him. He used to be one of the chief scientists at Microsoft. He invented LinQ, for instance. And in his presentation, he said things like, TDD is for pussies. There's only one true way to develop software, and then you put it into production. It will fail, and then when it fails, you just roll back to the previous version. It's as simple as that. There's no way you can pretend that you can test that it will work. So don't bother testing. Testing is for pussies. So all this test-driven development crap, forget about it. If your company does test-driven development, what do? You quit. Leave. Go away. You hand in your resignation today. Writing tests is waste and TDD is for pussies. So there was, I think, sitting and thinking, crap. Testing is not something that I should advocate anymore. This guy who obviously knows better than me and everyone else just declared testing, you shouldn't do it. So what else could I talk about today? So I remembered the title that I came up with, Moving Fast Without Deploying Broken Things. So preventing broken things doesn't work. So maybe let's talk about deploying things. And there is an interesting term called quantum of deployment. Is the smallest number of steps with the smallest number of people and the smallest amount of ceremony required to get new code running on your servers. This is the heart of continuous delivery. So I could talk maybe about continuous delivery and talk about microservices and component-based architectures, which are all the rage these days. Well, basically, it's not something new. So it's not something new. People have been doing this for at least 10, 15 years, at least some people have, and now we have a name for it, thanks to Martin Fowler, microservices. So, but then again, most people that I come in contact with, they have a big black box of a monolith. And breaking down a monolith that has no unit tests into microservices to achieve continuous delivery, and then in the end, come to a place where you have small units of code that you can deploy without breaking things, is like crossing a river over a single rope bridge while you're drunk with a gorilla holding the rope. And of course you have to have pirates. So maybe also dangerous topic. But then I got to the end of the video of Eric Meyer and realized it was just a hoax. He made fun of the audience at the Agile conference. He managed for almost 60 minutes to stay really serious and say to an audience full of people that Agile is stupid and waterfall is awesome and whatever. So it was all a hoax to irritate the audience, and that means I'm allowed to talk about testing, I think. So hello again. Yes, testing is awesome, we're allowed to talk about it. So this is a PHP event about testing, so most people build web applications using PHP. So what are the parts in a web application? Any guesses? It's too early, not enough coffee. You cannot test your audience. Okay. Well, you usually have an area of your application, a tier or a layer or whatever you want to call it, that deals with presentation. But ideally, you have something called a presentation model that has, it's basically a really simple key value store that stores some data that some other part of the application has prepared, and then this is the only data that is available for the front-end stuff for things like views and templates. Your views and templates should not talk to the database directly. That's how we did it in the 90s. Under the presentation layer, we have the application logic. This is stuff that deals with abstracting HTTP, which is our I/O channel. It's the I/O channel, the thing that is really important, which is a domain logic, and the outside world. It does things like abstracting the HTTP request and the HTTP response, takes care of routing, and dispatches to something that some people who think it's a brilliant idea to adopt a model view controller to the web controller. You can also think of it as a handler or a processor. Whatever you may call it, it's a piece of code that gets executed and then dispatches into the domain logic, which is where all the interesting stuff happens. This is where you implement your business rules, your workflows, your business processes, where you make your money. And then the final layer under that is persistence. At the end of the day, we need to store data somewhere and need to be able to retrieve it. So how can we test this? And one of the most important, if not the most important question when it comes to testing is finding the smallest scope in which you can test what it is that you want to test. So starting really, really large, the largest scope in which we can test, and here already the naming confusion in testing starts, because different people have different names for the same thing. And the root cause for that is you can have different categorizations for tests. So from an implementation perspective or from a scope perspective, this is called an end-to-end test. You have a real client on the one end and a real server on the other end. You send a real request from a real client to a real server, get a real response, send it back to the real client, and evaluate it inside the client. This is just a technology perspective or a scope perspective. It's end-to-end or a system test because you test the whole system. Now, the reason why you want to do such a test can be very different. You could do it to test whether or not a certain feature works correctly. Can I go to my e-commerce site, put something in the shopping cart, make a checkout, make a payment, and fulfill the order? Then it would be called a functional test or an acceptance test. You could also use the same kind of test to test aspects for the so-called non-functional requirements, which I find personally a really horrible term, because it means, are these the requirements that I need for my application to not function? Doesn't really make sense. I prefer the term quality goal. So you could use the same test to test whether or not it's fast enough, if the response time is fast enough. And then you would be talking about performance testing or load testing. You could also use the same test for cross-browser compatibility testing. Does this workflow work correctly in all the web browsers that I need to support? Does it work in Firefox? Does it work in Safari? Does it work in Opera? Or what have you? Which was the original idea behind Selenium, for instance. So you have one type of test, or one particular test, and depending on how you look at it, it has a different name, which confuses a lot of people. And unless you deal with this every day, I can really understand why this could be confusing. So we have this end-to-end test, and what can this look like? So the simplest thing that could possibly work, at least in, well, the most elegant thing that could possibly work and still be simple, in my opinion, if you want to implement such a test using PHP unit, which then opens up the third level of categorization that we can have, because we talked about the purpose of the test and we talked about the scope of the test, but just because you have the purpose and the scope clear doesn't necessarily mean that you are locked into just one tool to implement it. So one way of implementing this test could be using PHP unit. And it's really simple to use Mink, for instance, and Mink is a library that comes out of the Behat project that gives you a fake browser with a nice API. So in this case, we just extend PHP unit and implement a Mink test case that allows us to get a page model API for the site that we're testing. So in our test, we can say, please visit this URL, example.com, which is the URL that you should be using in testing if you're not testing a specific site, but just testing with something with a URL. There's an RFC for that. So we visit that URL and assert that the text of the HTML that is returned in the real response contains the text example domain. Of course, it's also really slow because we have the latency of the network. And at the time when I executed that test, it took about 1.5 seconds. So that's a problem that we have to deal with if we do end-to-end testing. They take longer. We execute more code, and in this case, we have network latency. A feature in PHP unit called test docs, which takes the names of your tests and prints an executable specification or test documentation, whatever perspective you want to have on it, just by running the tests. And in this case, we see we're testing something that is called application, and we have verified that the example page contains example text. This is a useful representation that you can use in a discussion, in communication with non-technical stakeholders of the project. It really makes a lot of sense to use something like that. And then, of course, you have tools such as Behat that take a behavior-driven development approach and allow you to express the same test that we just had, which was, from a scope perspective, an end-to-end test, and from looking at it, a functional test or an acceptance test, just with a different notation now. And there we can say, given I'm on the root document of my site, then I should see the text example domain. And then I can run this with Behat, and it takes also 1.5 seconds. So just by using a different tool, it doesn't magically get faster. We are bound by the scope to the limitation of the execution time. So it's slow, which is a problem, but it's not the biggest problem. And let me tell you a side story of why it is a big problem, because let's wait until the next slide. It's also very fragile because these tests tend to break a lot. You are testing the thing that you want to test, your domain logic in most cases, indirectly through other layers of your application. And when the test fails, you don't get as precise of a feedback as you would like to get. You get, of course, the information, this feature is broken, is already very useful, but you almost executed all of your code, and now you need to find out where something is broken. And this is something that is not unique, of course, to PHP applications. And Uncle Bob blogged about this a while ago, and he observed the same thing happening even more extremely in the Rails community, which has adopted the strategy of writing hordes of Cucumber tests, Cucumber being the behead of the Ruby world, tests that drive the applications through the web server, meaning if you drive the test through the web server, you're doing end-to-end system-level testing. This leads to slow and fragile tests and breaks many of the rules of test-driven development, which tries to keep tests from coupling to unnecessary system components like the user interface or persistence. So the problem with that is you want to test something, you cannot test it directly or choose not to test it directly. You test it indirectly through the user interface using real requests and real responses, which on the one hand makes it slow, and on the other hand it makes it very fragile because the test can fail when you make changes to other parts of the system that are not the part that you're actually testing. If you change the markup of your site, if you turn an H2 tag into an H1 tag, and you're using the H2 in a CSS selector and an XParse expression in your Selenium test, then your test will fail, but you have not changed the thing that you're testing. So that's not a good thing. And Uncle Bob goes further in saying, if you are doing behavior-driven development, you are doing test-driven development, and all the rules of good test design and decoupling still apply. You don't get a special license to create highly coupled tests just because you're doing behavior-driven development. So leaving the scope of end-to-end, this next thing that is smaller than end-to-end is so-called edge-to-edge. And edge-to-edge means this is a test that is as end-to-end as possible without leaving the scope of the PHP runtime in our case. So we are allowed to talk to the database, for instance, we're allowed to talk to persistence and everything, but we don't use the network, we don't use HTTP, we don't use a real client and a real server to communicate. We basically instantiate the application, create a fake request, and let the application run, and then look at the response that is generated by the application in the same process, because tests and tested code run in the same PHP process. And of course, the application has to be built and designed in a way that allows this. And the current generation of the most popular PHP frameworks make it possible to do just that. So in essence, we have an entry class, an entry object into our application that could be, for instance, called application, and that just has a run method that accepts a request and a response object. The response object is really, really simple, just a key value store that other parts of the code put data in that then gets passed on into the presentation model, for instance, and then we can render it depending on what kind of request we got. And that puts us into a position where we can write a homepage test, a test for our homepage, and ensure that we have a navigation. So we run our application with a request, and then use a search true to figure out, okay, does the response object now, after we run the application, after we simulated the real request, does it have this data called navigation? And one thing that I don't like about this is the usage of assert true, which is the most generic assertion possible that we have, that you should only ever use when you really want to make sure that a value is true. The test becomes much more concise and precise in what it does if you use a specialized exception, assertions such as assert response has data. And it's really simple to implement your own assertions in PHP unit. Just in case you want to implement your own assertions, this is how you do it. Assert response has data, for instance, delegates its work to a data exists constraint that is then passed on to assert that. All assertions that are part of PHP unit internally do exactly the same thing. And in case you're wondering, data exists constraint is really, really simple, just takes the response object and then the name of the data that it expected in the matches value in the matches method, and it returns whether or not that is there, and everything else is taken care of inside of PHP unit. So that was a short detour through internals of PHP unit. So the next thing smaller after edge-to-edge that we can test is collaboration between objects. And it doesn't really matter if this is just 2 objects or more. If it's more than 1 object that we're testing, and if it's less than edge-to-edge, then it's this kind of test. And here, the naming gets really fuzzy. Most people call this integration tests, although other people use the term integration tests for testing on an end-to-end level. So take your pick. I call them integration tests because it tests the integration of 2 or more objects. And one example for how such a test could look like, this is an example from the code base of a team that I was helping, I think 2 years ago by now. And they have these workflow objects that talk to backends and services and interact with the request. And of course, the execute method has more code than is shown on this slide, but I redacted it a bit so that it, not redacted, reduced it, so that it fits on this one slide. So if we want to test the execute method, what do we want to test there? It doesn't really have a return value, but what we are interested in here is the collaboration, the communication with other objects. And of course, this would not be a problem if we were using stubs and mocks to replace our collaborating objects with test doubles. We could use a mock and say, for this test to be successful, we expect the do work method to be called with these arguments and so on, but we don't want to replace our collaborating objects with objects that look like the real thing and do nothing. We want to have an integration test. We actually want to execute the real code. And this motivated a new feature in PHP unit that was introduced in PHP unit 4, which came out at the beginning of this year. And the feature is called test proxies. So what a test proxy gives you is an object that looks like the real object. You have the mock object API on it, so you can say, for this test to be successful, I need these method calls with these arguments and so on, but the real code is executed. So it's a hybrid between the real object and the mock object. And for integration tests like this one, this is really, really convenient and powerful to express the things that you want to test. And of course, we are only left with one smaller scope than that, which is testing 1 unit of code in isolation from all of its collaborating objects. And for that, we use stubs and mocks and test a unit of code in isolation from everything else. And of course, you cannot get away with just one type of these tests. If you only do unit tests and test everything in isolation from everything else, you don't know whether these things actually work correctly when they have to collaborate in production. There's a very famous example for when this really failed. So a couple of years ago, NASA sent a probe to Mars, and the development of the software for the navigation component of the probe was split into 2 teams. And the 2 teams rigorously tested their parts of the system in isolation from the other part of the system. They forgot to do integration testing. They had a disintegration test in the orbit of Mars when the poor probe crashed and burned, which was a very, very expensive test that cost a couple of billion of dollars. So what had happened? The one team in the US used the imperial system, and the team in Europe at the European Space Agency used the metric system. And of course, they were only passing floats around without any type or unit, measurement unit attached to the float. And of course, the calculations failed. Also, I've seen teams that only use unit tests. And of course, their code is very clean and their code is well tested, but they're not necessarily building the right product. So there's a saying that unit tests help you build the product right, and the other tests, especially the acceptance tests, tell you that you're building the right product, and those two are not necessarily the same thing. So that's also very important. And of course, it's very easy when you don't have any collaborating objects and you don't need to stop or mock, and you can just test the thing that you're testing, but that happens so rarely that you have isolated objects, mostly value objects that you have floating around. So, but it's in these small objects that you usually have your domain logic, which is responsible for representing concepts of the business, information about the business situation, and business rules. State that reflects the business situation is controlled and used here, even though the technical details of storing it are delegated to the infrastructure. This layer is the heart of business software, says Eric Evans in his book, Domain-Driven Design, that I think every developer should have read at some point in his or her career. And the important thing here is that if you cannot test the heart of your software directly, meaning you don't have to go indirectly through additional layers, using unit tests and in isolation from persistence and the web context, then you are in for a lot of pain. And I've seen this happen over the years to quite a few teams. I once worked with a team that actually had a really good product until they realized that they built the product in a completely horrible way. And when they wanted to start testing, they were not able to test using tests that were smaller than end-to-end tests with Selenium. And they wrote, or basically recorded, all the tests they needed using Selenium, and then it took them at least 23 hours to run the test suite. And this is not a short feedback cycle. And of course, all these tests were very, very fragile. They never managed to run the entire test suite without at least a couple of dozen tests failing. So eventually, they deleted all the tests because those tests only slowed them down. And eventually, the company went under. Really extreme example. Other example, about a year ago, I talked to a team that exclusively uses Behat to test their application. Only end-to-end level tests expressed using Behat. And don't get me wrong, Behat is a wonderful tool for writing down acceptance tests in a notation that both the technical participants of the project and the non-technical stakeholders, like the business of the project, can understand. And there's a lot of value in that. But it's so easy and seductive to write all these Behat tests as end-to-end tests that send real requests to real server and so on, which makes their execution really slow and makes them also fragile when something in the front end changes. So their problem was, their biggest problem was not that it took 6 hours to run the test suite. Their biggest problem was that when a test failed, it usually cost them at least 1 man day to find the root cause for why it was failing. Because the more code that you execute while a test is running, the more code you have to look at, the more code you have to debug to get to the bottom of the problem, and then you can fix it. So you need a healthy mix of both the small unit tests and the larger tests. Like I said in the beginning, most important question is finding the smallest scope possible that allows you to test the thing that you want to test. And of course, you can do even larger tests than end-to-end tests. We have one team that a couple of times a year does something that is more than end-to-end testing within the software. So they have an e-commerce platform, and the first part of the test is automated. They go to the site, search for a product, go to the product detail page, put the item into the shopping cart, make the real checkout, make the real payment, and then the part starts that you cannot test in an automated way. They have people in their logistics center, in their warehouse, looking at how the product is retrieved from the shelf. Is it put into the right size of a box, and is it labeled correctly, and does the handoff to the logistics company work correctly, and so on. And that's not something that you do in continuous integration, otherwise you run into all sorts of issues, and you don't want to do that. But it's interesting that you can have a lot of different scopes of testing, and you basically need all of them, otherwise you run into problems. There is another interesting categorization, if you will, of testing that gives us three other criteria to evaluate the effectiveness of a test, which is fidelity, resilience, and precision. You want tests that have a high fidelity, which is a test that is very sensitive to defects in the code that it tests. So if you have a piece of code and you have a test for it, and if you manage to break the code that you're testing and the test still tells you that it's not broken, people start losing faith, losing trust in the tests, because they see the code fail in production, fail for real users, and the tests tell them everything is fine. You don't want that. A test should be resilient. If I have a test that tests a unit of code and I change something somewhere else, it should not have an effect on the code I'm testing. If the test fails and I have not changed the code that it is testing, then my test is not resilient, which can be a smell that my software is broken at some place, that I get spooky action at a distance, whatever you want to call it, and you want to isolate your code from that. And the test should be precise, that it tells you exactly where the defect lies. So the less code you're executing while a test is running, the higher the precision and the more resilient it is.